Alright, to make this you're going to need some vinegar, ice cube tray, some galvanized nails, copper wire, and an LED light. Then you're going to take your copper wire and wrap it around your nail. And you want to leave kind of a tail, a little bit of copper wire out. And when you put it in the ice cube tray, you want that little tail end of the copper wire to go into the next well of the ice cube tray, so into the next little ice cube piece. So once you have all of that, you just keep doing that, and once they're all filled in, you pour the vinegar into each well of the ice cube tray, and that is what is going to create your circuit. Then all you do is you put your LED light in, and it should turn on. And here you can see the light a little bit better. Pretty cool, right? Alright, what you'll need for this is some magnets, some rare earth magnets is what we're using, copper wire, wire cutters, and a AA battery. And then you just take your magnets and put them at the bottom of the battery, and you take your copper wire and cut it. And the most important thing and the hardest part of all of this is you really want your wire to be balanced on either side. So you want to try to make it the same length on either side. That way it balances out. And then you want it long enough so that the copper touches the magnet. So this is demonstrating something called the Lorentz force. This is the force that is generated when electricity moves through a magnetic field. So our copper wire is conducting electricity from one end of the battery to the other. As it moves through the magnet on the negative side of the battery, it creates a force which causes the wire to spin. And you can really play around with it and see the closer that we got our copper wire to the magnets, the faster it spun. I really encourage you to just play around with it and have fun. Create a lot of these and write down the differences that you notice. What you need for this is a multimeter, some copper wire, some test leads, a lemon, some nails, and wire cutters. I'll tell you this, you need one galvanized nail for each lemon that you use, and the more lemons you use, the stronger your battery will be. So what you're going to do is just cut a piece of copper wire, and you only need one kind of stick for each lemon. We're only using one lemon for this. And then all you do is you put the copper wire in the nail in your lemon. I'm not sure what I did there. And then you hook up a test lead to the copper wire and then to your multimeter, and then you hook it up to the nail and then to your multimeter to create a current. Do not do this without your parents' supervision. Safety is very important. What you're going to need is a 9-volt battery and some steel wool. We're using a piece of cardboard just to protect our table. And then you just simply touch the battery to the steel wool. And when both battery terminals touch the steel wool, the electrons from the battery move through the steel wool to make a complete circuit. And the electrical current heats up the wire. And the heat causes the iron in the steel wool to react with the oxygen around, and that reaction causes the sparks that we can see. Alright, so what you'll need for this is some vinegar. I have a little dish here, aluminum foil, some thin cardboard, some tape. It doesn't have to be electrical tape, it could be even Scotch tape. Some test leads that have been cut and stripped on the end, some pennies, and a multimeter. Then you're going to start by just tracing your penny out onto the thin cardboard and cut a bunch of circles. I have a bunch right here, and then you soak those little cardboard circles in vinegar. And you want to do the same thing with tin foil. I folded the tin foil and then just cut a little circle, and there's a bunch. And then you're gonna start your battery. So first I put the test lead wires down, and then I put the penny, and then a piece of cardboard and tin foil, penny, cardboard, tin foil. You just keep layering that. The bigger your stack, the more powerful your battery will be. I think I had 8 or 9 pennies, and you can see I will hook it up and we'll test the voltage. What you need for this is tinfoil, Christmas lights, tape, some batteries, 9 volts, some AA or AAA, paper, and wire cutters. You want to cut the bulbs off and then strip the wires so that you can actually see the wires. And then you want to tape it, tape the tinfoil to paper, and then tape the wires to the tinfoil to create a circuit. And you can create a parallel circuit like we have here, and we're using 2 AAA batteries, but you could use 1 AAA, 1 AA, 2 AA, whatever you have on hand. Or you can create a series circuit like we have here, and we're using the 9-volt battery with this. And then we wanted to see if we could make the lights brighter, so we took one of the lights out of the circuit and then reconnected the circuit to see if we could make the lights brighter. And we did! This is super simple. All you need is some grapes and a knife and a microwave. And then you want to cut the grapes in half, or almost all the way in half, leaving just a little bit of skin between them. So the electromagnetic waves in the microwave cause electric current to move back and forth between the 2 halves of the grape. That current is concentrated on that one little piece of skin between the 2 halves, and that'll heat up and dry out. Then the current has to move up through the air, creating a spark. All you need for this is a piece of PVC pipe and some Christmas tinsel. Take 3 to 6 strands of tinsel and tie them together on each end, about 6 inches apart. And then you cut off the excess on the end. And when you rub the pipe in your hair or give it a static charge, you're giving it a negative static charge. The orb is at first attracted to the pipe because it has a positive charge, but as soon as the orb touches the pipe, it picks up a negative charge. And since the pipe is negative and the tinsel orb is now negative, they repel away from each other, and it makes the orb levitate. What you need for this is insulated copper wire, a D-cell battery, a nail, and then something that you can pick up with your magnet. Paper clips might work better than these nails, but that's what we had. So first you're going to take your nail and wrap your wire around your nail. And then once you have it all wrapped up, you can take off the coating, strip the wire, so you can see the wire, and then you will attach it to either end of your battery. You can see that it's not picking anything up right now, it's not magnetic, and then as soon as you hook it up to the battery, it's magnetic. What you need for this is a cutting board and a knife, a couple potatoes, some galvanized nails, some pennies, a multimeter, and some test leads. And then what you're going to do is you're going to cut your potato in half and then cut slits on one end, and that's where your penny will go. You're going to just stick your penny in those slits and then stick your nail on the other side, and then you're just going to hook it up to your test leads. So you're going to hook one part of your test lead to the nail and then the other part to the penny and go around to create a circuit. And once you have them all hooked up, you will hook up your multimeter so you can see how much voltage you have. So what do you think that we could power with our potatoes? It's hard to see, but we did have enough power to power up this little LED. Did you try any of these out? I would love to hear about it. Let me know.